Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of Pythagorean Theorem on a coordinate plane. This is standard 8.7D in the great state of Texas, and we are using item number 22 off the 2017 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got two different points. They don't have them plotted for us, but they give us the coordinates. So point J is -4, -6. So here's my -4, and my -6 is down here. So I'm going to just put a little right there, little dot right there. So there's my J. And then K is 4, x of 4, and y of 4. So let's go ahead and put that on there. All right, so there's my K. And they just want to know which measurement is closest to the distance between point J and point K. So I need to figure out what that distance is. But it is a diagonal. I don't need to try to count how many squares or units there are. There is an easier way, and it might not seem evident at this point, but that diagonal line can easily be turned into the hypotenuse of a right triangle. So let's see what happens if I put this dot right here. All right, so I'm just going to put my own third dot up here. But what I did is it is directly above point J, and it is directly across from point K. So now I have a right triangle. And now I know what to do with right triangles. I know that these two are called the legs. I know that this length that I'm looking for is the hypotenuse. And there is a formula, a squared plus b squared equals c squared, the Pythagorean theorem that becomes very helpful when trying to find side lengths of a right triangle. So the legs are a and b, so I'll just label those two a and b, and the hypotenuse is always c. It's always directly across from the right angle. And so why does putting that point there help us? Well, I can tell the distance of a because it runs from -6 down here up to +4, so that means a equals 10. So that's got a distance of, let's make that a 0 a little bit clearer, there we go, a distance of 10. And then b, it runs from -4 to 4, so that's 8. All right, so we can actually plug that in. And what this means is that if we were to draw little squares off of b and off of a, and it might come off our table a little bit, if you were to add the a squared and the b squared, the areas of those two together always equal the area of that c squared. That's what that means. All right, so let's say 10 squared plus 8 squared equals c squared. So I'm just substituting in my 10 and my 8 for my a and my b, so that's 100 plus 64 equals c squared. So that's 164 equals c squared. That is not my answer. And so we have to still take care of that exponent. And the way we get rid of an exponent is the inverse operation, and that is a root. So since it is squared, I'm going to square root this. So the square root is going to cancel out that squared. So c equals the square root of 164. So let's see what we can figure out about 164, estimating at that. All right, so below it is going to be 144. That's 12. And above it is going to be 169. That's 13. So it's between 12 and 13. But look, it's only 5 away from 169. But it is 20 away from 144. So it's a really close. So it's probably going to be like 12.8, 12.9. Call it 12.8. But it's really close to that 13. And as you can see, we don't have any decimals over here. So let's just round it up. Our answer here is going to be H.